What's the situation with Taiwan's semiconductors? I think I only know about TSMC, to be honest. Minister, I assume you're also in contact with Taiwanese officials. So what is Taiwan's situation?
To put it simply, TSMC is Taiwan's insurance policy, and Taiwanese politicians are very open about saying that.
Whether that's economically or militarily.
TSMC is our country's insurance policy. It's that much a source of pride for Taiwan, and it's their central pillar. But now, NVIDIA's Jensen Huang is joining forces with them. This power is immense. So this triumvirate, the Taiwanese government, TSMC, and Jensen Huang, is now making its move. The biggest reason I'm paying attention to Taiwan is that Taiwan has introduced something called an AI factory. But I was the minister in charge of smart factories at the Ministry of SMEs and Startups. At first I thought, oh, we need to upgrade this smart factory to AI. I was involved up to that point. Initially I thought it was like that, but upon looking into it, it wasn't. Jensen Huang said this: Taiwan's AI factory is a factory that turns data into knowledge. Sounds very plausible, doesn't it? So I looked into what this meant, and it's this. In the future, every factory will need two factories. One is the existing manufacturing factory that makes the product, plus an AI factory that attaches artificial intelligence to that manufacturing factory. To explain it simply, while making a conventional washing machine, you attach AI to it. But what kind of AI? When laundry goes in, the AI uses sensors to identify the properties of the laundry and automatically selects the wash cycle, meaning you just put the laundry in and you can just leave. It runs by itself. Taiwan is declaring that it will become the world's best at this kind of AI factory. In other words, they are transitioning from manufacturing powerhouse to AI manufacturing powerhouse.
So they are also making the AI itself, they are productizing it.
Oh, the moment I heard that, I felt this jolt, this chill. I thought, wow, this is serious. This is what South Korea should be doing. Because when I was the minister, I created something called CAMP, the Korea AI Manufacturing Platform. It's the world's first public-private partnership platform specialized in manufacturing. An AI platform specialized for manufacturing. Because, you know, our country is a manufacturing powerhouse. So we built that platform to accumulate all the manufacturing data generated from industrial complexes like the Changwon complex to use as AI data. But if we run that data through the AI factory that Taiwan is proposing, that could become the best in the world.
We always talk about AI development, but adding the concept of AI manufacturing, that shows immense business potential.
That's where it becomes profitable.
In your view, Kim, does Taiwan have sufficient capabilities for that? Please explain that ecosystem to us.
We targeted the Taiwanese market so aggressively that some people in Taiwan think DeepX is a Taiwanese company. We even set up a branch office there. Through that process, we came to understand Taiwan much better. And the reason we went to Taiwan in the first place is that it's the lion's den. The epicenter of system semiconductors is now TSMC, and related companies like Realtek, MediaTek, and others comparable to global Foundries are all there. The AI factory. I see it this way. TSMC used to be national defense priority number one, but one of Jensen Huang's goals seems to be becoming the next Morris Chang, and the realization of that goal appears to be the AI factory. It's a place where algorithms from physical AI worldwide can be fully tested on a simulation basis, enabling the creation of applied physical AI algorithms. In a way, the AI factory is becoming the foundry for AI algorithms.
By building this in Taiwan and holding it hostage, like TSMC's Silicon Shield, the idea is that if this gets destroyed, AI itself might disappear. Because the system semiconductors and the simulation matrix supporting AI would be gone, it would trigger an economic crisis. That seems to be the narrative they want to create, and that's the angle they're taking.
When Jensen Huang comes to events like Computex, he acts a bit like Warren Buffett. He gathers all the related industry CEOs for a meal and says, "You are all part of this entire industrial ecosystem that NVIDIA is building. AI, semiconductors, servers, everything. Don't engage in unfair competition and don't cause discord. If you do, you will be kicked out of the NVIDIA ecosystem." So this vertical integration isn't being done by a government. NVIDIA is doing it right now.
Server companies like Supermicro need to get allocations from NVIDIA to increase their revenue. Because of AI chips, revenues for data center-related industries have skyrocketed for several years. So he holds absolute power. He doubles their revenue every year. Yes, and as a result, the entire ecosystem collaborates and runs smoothly. We see this operating like a single system, and we also have to integrate with it. That's the only way to be part of that ecosystem. Looking at it this way, a corporation is doing the work a nation should be doing. And another point, which I think is worth learning from, back in 2013, Taiwan designated system semiconductors and AI semiconductors as national core technologies. The government provided massive large-scale support, like tax benefits. Even though TSMC was already making good money at the time, the government boosted this industry by pouring in subsidies and incentives worth $700 million. Taiwan is reporting that its national revenue from this sector has increased 68% this year compared to last. Based on this, advanced nations are forecasting 5% or 4.5% GDP growth. One point I want to make is yes, there's China and the US, but there is also the Taiwan model, and I wonder if we shouldn't be benchmarking them.
I believe this is extremely important. We must watch Taiwan closely. Another key pillar of this AI factory is using synthetic data to create digital twins, then simulating those digital twins and training the AI within that simulation. For example, every factory has different conditions, right? In the past, autonomous vehicles had to physically drive on the streets to collect data, but they don't do that anymore. They input data into a simulation and practice there. It's the same for factories. They create an exact digital twin, a copy of each factory, simulate it, and train the physical AI robots there. This is another area where Taiwan's TSMC and NVIDIA's Jensen Huang are currently focusing.
You, Minister Park, expressed regret that we should be doing this, but I believe we still have potential in the areas we excel at. China is innovating across all AI fields and moving toward an AI factory base, and Taiwan is becoming the manufacturing epicenter for the entire AI hardware system. That's fine, but my thought is, doesn't that leave a unique role for us?
For instance, Korea is also very good at digital twins. However, we haven't yet succeeded in connecting these digital twins to industry in that way. This is what I find disappointing. The Ministry of Science and ICT recently opened the third call for proposals for the National AI Computing Center. According to the proposal, the government is securing 15,000 GPUs, but the AI factory Taiwan is running uses 10,000 GPUs. This means we too need to produce some kind of concrete output with these 15,000 GPUs. However, the current ministry proposal allows a private consortium to come in and design it, which I find disappointing. If we had approached this with a true sense of urgency and deeper thought, couldn't we have produced something tangible? Instead, it just seems like they're making 15,000 GPUs available for startups to use, for academia to use, and that's about it.
Yes, with such a vague picture, it's a bit disappointing.
There should have been a concrete picture. Only then can we see progress.
And another thing, is there really a private company in South Korea that has operated 15,000 GPUs? I doubt it. For example, even what Samsung, LG, or Naver have doesn't amount to 15,000 GPUs. It just feels like a real waste.
You mentioned the need for the government to take the lead. Japan, for instance, is taking the lead, right? With Rapidus, they've invested and are saying, we are going to push further into the foundry business, utilizing their existing materials, components, and equipment ecosystem. What about Japan, Europe, or other regions?
For example, when Japan decided to pursue Rapidus, how did they persuade the US? They said, we are going to make AI semiconductors. And we are going to do 2 nanometer in Hokkaido. And what's more, we'll use renewable energy. The 3 major conditions for semiconductors are water, power, and people. Water is easily accessible in Hokkaido, and power will be renewable. And we will pursue 2 nanometer AI semiconductors, which Korea isn't doing. They persuaded the US with this. This implies that, conversely, we were already lagging behind in the AI semiconductor space. Also, isn't Japan's prized supercomputer Fugaku? Well, they are building Fugaku Next. It will operate starting in 2030, and this Fugaku Next is for AI for science. They've set a clear AI goal. The areas we excel in, basic research, materials development, we are going to own that space. And Europe, compared to the US, is still very much focused on AI ethics. Europe's strategy is to unite. Now, Taiwan has put forth the AI factory, championing AI for manufacturing. China has goals like AI convergence, and we will dominate the physical AI era. So what about Korea? AI for what?
That is probably the most important message of this discussion today. We must create this, right?
I heard you recently visited Rapidus. Could you share your impressions?
They finished the groundbreaking this year, and then they secretly brought just 15 people, representing about 15 global companies, inside the factory for a tour. As you mentioned, it's 100% renewable energy, and the interesting part is the entire building floats. The first place we went was the basement. Down there are tons of pillars, and they are all connected by spring-like mechanisms, so the building is suspended. This means that even with significant shaking or an earthquake, it's fine. Then they said, this is a 2-nanometer wafer produced just 14 days. What they were emphasizing by showing this was, other countries' foundries might take 4 or 5 months to get a wafer out, but we'll get it out in 2.5. We are taking on the challenge of cutting the time in half while doing 2 nanometer. I saw them making that challenge. I felt this was somewhat like a nuclei asset. If in the 20th century 9 countries shared nuclei weapons and held hegemony, in the 21st century the nation that possesses core AI semiconductor technology will hold the hegemony. That's why my obsession with core AI semiconductor technology is so strong. We can talk about, what if we had possessed nuclei weapons in the 20th century? We didn't possess them. And because of that, we face difficulties. So if we can possess a powerful strategic asset like AI semiconductors in the 21st century, what value will that bring to our nation's global standing? As I see it, the US and China are already taking the hegemony. Having seen the iPhone mass-produced at Apple back in 2017, I realized the US has already secured it, and China will unconditionally try to secure it. Those two are already locked in. Among small countries, there's Israel, a company called Habana Labs, which has now been merged into Intel. But before the merger, I believe it had the most promising technology among the server NPU companies I've seen. Israel also has outstanding on-device semiconductor companies. That's why we wanted to compete with them. To show we were better, we demoed putting butter on the chip. When the competitor's chip completely melted, running the same AI workload, theirs melts, but ours doesn't melt at all. That's how good our power efficiency is, and that's what's important. After them, Europe is also making moves to secure hegemony, and Taiwan has a bit of a chance. That leaves Korea and Japan. The rest, in my view, are in territory that will be difficult to cover for hegemony. Personally, I think Korea possible. But Japan, that's a question mark. They're different from the past. They used to have this cohesive focus on cutting-edge technology, but recently they've become Galapagos-ized regarding advanced tech. So I wonder, wow, can Japan really pull all this together? I believe what we have right now, what we're holding, is much more competitive than that. If we nurture it well, I see potential.
Japan was making 28 nanometer chips, and now they're suddenly saying they'll make 2 nanometer.
Even Japan shouldn't be complacent. If we're talking about system semiconductor capabilities, I don't think Japan's inherent capabilities are bad. It's not necessarily that we are ahead, but rather that their passion for the cutting edge has cooled off quite a bit.
We've now briefly reviewed the situations in the US, China, Taiwan, Japan, and Europe. What I'm most curious about now is the current state of South Korea's AI semiconductor industry, and perhaps what our breakthrough might be. First Minister, you mentioned this in your book, The 3 AI Superpowers, but could you briefly summarize the current status of Korea's AI semiconductor industry ecosystem?
We are still too focused on memory semiconductors. Samsung Foundry needs to step up. So the crucial question is, how can we expand our market share in system semiconductors? This has become vitally important. Korean NPUs, for example, DeepX, is working on on-device, while Rebellions or Furiosa AI are working on server-side, right? That's why in my book, The 3 AI Superpowers, I gave them the title, The 3 Musketeers of Korean Semiconductor Design. I believe we need to provide policy support so that these 3 musketeers can grow to become the Jensen Huangs of Korea.
Korea lacks experience in mass-producing system semiconductors, and we don't have companies making huge profits from it. Was there a decisive event that caused Taiwan to succeed while Samsung Foundry fell behind?
This is what I think. 2014, 2015, and 2016. Those 3 years were the absolute worst for Samsung. First, in 2014, NVIDIA's Jensen Huang offered to sell CUDA to Samsung. But they refused. If they had bought it then, the entire game would have changed. Then, 2015 was the year Jensen Huang first came to Samsung to make HBM, got rejected, and then moved to SK Hynix. And 2016 was the year Samsung, which had been making Apple's AP, application processor, was completely cut off. I see this as the decisive period. But I see that Kim Lok-won was at Apple in 2016. I'm very curious about the situation back then.
Apple cut off the AP manufacturing that was originally done at Samsung Foundry and moved it to TSMC. In the book TSMC's Semiconductor Empire, written by Maurice Chang, he highlights it's painful for our country, but he describes taking the Apple AP volume from Samsung as TSMC's decisive winning point. It was after that point that TSMC ascended to national defense status. But when I was at Apple, right when I joined, both Samsung and TSMC were doing it, dual sourcing. That particular point in time, I think, was a very unfair situation for the employees at Samsung Foundry.
Because an advanced semiconductor fab, it doesn't just produce fancy chips that work perfectly right from the start. It doesn't work like that. It's a buggy mess. Even at Apple, when you first look at a new chip, all the analysis and simulations don't line up. So when the semiconductor comes out, it doesn't work correctly. You have to somehow fix it, tuning it through manual work and additional analysis. In that process, you end up demanding various changes from the foundry folks. If the customer gives an order to a chef, the chef has to be able to make it perfectly. You can think of it as trial and error, changing the environment in the kitchen, the foundry. This process of hazing, metaphorically, the foundry to get the absolute best flavor is the ramp up. The factory has to reach that level to achieve mass production. Through this process, optimization points for various designs naturally emerge and overall yield stability improves because they pull so much volume. When Apple finds a partner where the skill and quality align, they can rise together. But Samsung lost the batter, the client, that could do this for them. Even when NVIDIA demanded a year ago, expand the CoWoS factory for NVIDIA, TSMC didn't listen. Even if NVIDIA says, give us 2 nanometer first before Apple will pay more money, we're number one now, TSMC still won't give it to them first. The reason is, the one with the incredible ability to take a completely messy factory and ramp it up to mass production is Apple, with its decade of history. NVIDIA, this nouveau riche comes along and says, I'll pay more, give it all to me. But TSMC tells them, even if we give it to you, you can't handle it. But they just don't listen. In my view, people talk a lot about Samsung Foundry's competitiveness, but there were likely more external factors than internal ones. But still, Samsung Foundry is the global number 2. They are managing to mass produce 2 nanometer. If you look at this year, there's no other competitor that can do this. Not Intel, in my opinion, or Rapidus is still a story for 2 or 3 years down the road. Since we have Samsung Foundry, wisely reviving it and making it succeed is critically important for our national competitiveness.
So in Samsung Electronics' case, is the situation that they just don't have a partner right now, like the one Apple and TSMC had in 2016, to get in sync with?
Currently, well, there's the recent Tesla case, but I actually look at it this way. Business involves supply and demand, and we expect demand to surge in the AI era, so that will have an impact. But what sits above all of that is geopolitics. For example, the US government recently started talking about potential tariff reductions for semiconductor fabs located in the US. Because of that, volume that might have gone to TSMC could now go to Samsung's fab in the US, right? Within these relationships and geopolitical dynamics, there could be variables. So I'm just hoping that Samsung can rebound a bit on its technology and find an opening again.
Park, do you think it's right for national investment to also go, in a way, full force into the foundry sector?
We must. But the government must invest in a way that sets the stage, in a way that builds the AI semiconductor ecosystem. Rather than intensively supporting one specific conglomerate, the important thing is to play the role of a connector that links that large corporation with startups.
On that point, we also decided on Samsung Foundry for our 2 nanometer product, the DXM2, and announced it. We believe this 2-nanometer chip has tremendous potential. Samsung's 2-nanometer process has many issues and much talk around it, but that's because the GAA, Gate-All-Around process, provides an additional 25 to 30% power reduction compared to the existing FinFET process. Samsung is the first to have introduced GAA at 2-nanometer. If they can lock down the yield here, the power performance efficiency should also be excellent. Rather than rushing to 1.4-nanometer, it seems their internal ambition is to make the 2-nanometer process their last line of defense, like the Nakdong River line, stabilize the yield there, and then launch an Incheon landing, a major counteroffensive. If they stabilize the yield here and build a rich ecosystem within 2-nanometer, the power efficiency is so good I'd want to keep using it. Therefore, if we are to prepare for 2-nanometer, I believe that the domestic industry and government putting effort into building the 2-nanometer ecosystem could be a very significant strategic technological move.
It really seems like, in a way, 2-nanometer could be Samsung's great comeback story and an opportunity for the entire Korean semiconductor ecosystem.